Hey kiddos, welcome to lesson 1 of unit 5a where we will introduce tape diagrams. Your learning target is I can use a tape diagram to find an unknown amount in a situation. We're going to start digging into solving our algebraic equations, and so I want to go over the goal, which is when we solve algebraic equations, we are just trying to isolate our variable, whether that's an x or a y. We want to get it alone. Meaning, if we're solving for an x, our goal is to figure out what one positive x is equal to. Our variables want to be alone. So I have this drawing here on a scale, and we have these two x's. One would like to be by itself, and then we have 4 1s. This equation represents 2x equals 4. And if we want to get one of those positive x's all by itself, one thing we can do is divide both sides by 2. Effectively kicking 1x off the scale, kicking 2 1s off the scale, and coming up with 1x is equal to 2. And in our next several lessons, we're going to be using these tape diagrams. So here are two very general examples of tape diagrams. And what these are is we always have a total quantity. So in this top one, our total quantity is C, and then it's broken up into other pieces. So for this first example, we have 4 pieces that are all A plus B. And what's inside the diagram is equal to our total. So we could write an equation with this, and we could write at least 3 different kinds of equations. One thing we could do is we could just tally up all of the A's and B's we have in there. So there's 4 sets of A plus B, and we could set that all equal to C. That's a really obnoxious way to do that. And now that we know how to combine like terms, I think that's an easier way to do this. So if we have 4 sets of A and 4 sets of B, then what we have is 4A plus 4B equals C. So there's one equation we have. Or we could write that in factored form, where we pull that 4 out. And so what we have is 4 sets of A plus B all equals C. And with these general situations, we can go ahead and just choose some values that would make this equation true. And there are 2 ways to do this. There's an easy way and then a little bit more challenging way. Let's start with the easy way. So for our easy method, we can choose any 2 values for A and B, and then we'll just calculate and get C, the total. So I might choose, I'm going to say if A equals 10 and B equals 3, then I can just plug that into either of these equations over here and solve. So I could say 4 sets of 10 plus 3 is equal to 4 sets of 13, which is also going to equal C, which would equal 52, which means that our C is equal to 52. So I could say back on over here, if A equals 10 and B equals 3, then C equals 52. And I'm actually not going to worry about the difficult method right now. Let's just go with the easy method. So I want you all to pause this and try writing an equation and choosing some values to play around with this second tape diagram, and then head on back and see what I come up with. Maybe compare notes with your table mates. So here's what I came up with. My equation is 4x plus y, and sorry, let me get that green, is equal to z. And then I just chose some random values for x and y. I chose x equals 10 and y equals 3. Plugged them into my variables. So instead of 4x plus y equals z, I had 4 times 10 plus 3 equals z. So 43 equals z. So I came out with if x equals 10 and y equals 3, then z equals 43. All right, let's see how these work with some story problems. All right, we have Sophie. So Sophie made 50 flyers for 5 volunteers in her club to hang up around school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and then divided the remaining flyers equally among the 3 remaining volunteers. So bust out your highlighters, and then I want you to color coordinate. Where do you see the parts of the story represented in this diagram? Let's start with 50. So 50 is our total. It's our total number of flyers that Sophie has. The 5 volunteers, I'm going to pause on that one and just move forward. But we know that she gave 5 flyers to the first volunteer. Here are those 5 right there. And then she gave 18 flyers to the second volunteer. Here are those 18. And then the remaining 3 got the rest of them equally divided. So we don't know how many they each got. That's why they're X. But 3 people got X number of flyers. I'm realizing I think I spelled flyers wrong. Oh well. So here's where all those parts show up. Now let's write an equation that represents the situation. And I think your notes say something else. Believe your notes, not this. We're not quite to T diagrams yet. So our equation could look any number of ways. I'm going to start with, I always like to start with my variables. So we have 3x's plus 5 plus 18 all needs to equal 50. And we can combine our constants. So 3x plus 23 equals 50. Now I want you to think about just visually, how can we split this apart or use this diagram to figure out what these 3 quantities are? Go ahead and pause and brainstorm. So what I can see visually here is that this quantity right here is 23. So I could say that 50 minus 23 will give me the remaining flyers, which means that the other portion right here equals 27 total flyers. And if we know that these 3 people had an even number, then we could say, well, those 27 divided by the 3 parts we have will tell us how many flyers each got. So since 27 divided by 3 is 9, that means our x equals 9. So each of these would be 9 flyers. Let's try one more. In this case, we have my dear friend Billy Bobob, and he is hungry for apples today. So he bought 4 bags of apples. Each bag has the same number of apples in it. After eating 1 apple from each bag, he has 28 apples left. We have 3 diagrams here, and only one of them represents this story. So I want you to pause, try this yourself, and decide which of these diagrams do you think represents the story, and then come on back. So the correct answer is diagram C. That's because we have our total of 28, which represents the number of apples left in the bag. And we have those 4 sections, which represent each bag of apples. And within each bag are X number minus the 1 that he ate from each bag. So next, what part of the story does X represent? Go ahead and pause, write down your thoughts, come on back. So X is our unknown, and in this case, the thing we don't know is how many apples were in the bags before he had his snack. So X represents the number of apples in each bag before his snack. And now let's go ahead and write an equation. So again, we can use the distributive property, or we can write it in factored form. So I could say I have 4 groups of X minus 1, which equals 28. Or I can expand that out and say that I have 4x minus 4 is equal to 28. And now if you think about how these negative ones here represent him eating an apple from the total, we could add those back. So I'm just going to do the opposite. I'm going to add 1 to this side, add 1 to this side, add 1, and then those kind of just disappear right there. And what I instead have is 32 total apples is equal to my 4 x's. And from here, this is a one-step equation. We could say that we could just divide both sides by 4. And then what we get is 8 is equal to x. So we know that there are 8 apples in each bag. All right, go ahead and grab your journal problems. Please, 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 please let me know how I can help you as you work through these. I know that not everybody got a ton of algebra last year. Let me help you. All right, you guys are awesome. Best of luck. Bye.